Stop what you're doing. Right now. Pinch yourself. Go ahead, do it. Feel that? There's something there. Something experiencing that pinch. Something aware. And that should terrify you. Because we know exactly what your skin is made of. Carbon, hydrogen, oxygen, nitrogen. Just atoms. We know what your nerves are made of. The same stuff. We know what your brain is made of. 86 billion neurons. 100 trillion connections. All of it atoms. Just atoms. But where is the thing that felt the pinch? Point to it. Go ahead, try. Where is your mind? You'll point to your head. Everyone does. But here's what disturbed even Richard Feynman, one of the greatest physicists who ever lived. When we open up the head, when we look inside with every instrument we've ever built, we find neurons. We find electrical signals. We find chemistry. We never find the thing that's doing the experiencing. And this isn't some minor gap in our knowledge. This is what Feynman called the most profound mystery in all of science. The one problem that made him admit, we haven't got the faintest idea what's going on. By the end of this, you'll understand why everything we've discovered about the universe still hasn't brought us 1 inch closer to answering this question. And you might walk away wondering if reality is far stranger than any of us have dared to imagine. Let me start with something that seems simple. Look around the room you're in right now. You see colors. You see shapes. You hear sounds. Maybe you feel the chair beneath you. All of this seems obvious, natural, just the way things are. But stop. Think about what's really happening. Light bounces off objects. Electromagnetic radiation. Photons. They enter your eye, hit your retina, trigger electrical signals in your optic nerve. Those signals travel to the back of your brain, to the visual cortex. Neurons fire, patterns form, and then something extraordinary happens. Something utterly inexplicable. You see red. You see blue. You experience the world. But here's the problem. The light isn't red. The light is just electromagnetic radiation with a wavelength of about 700 nanometers. There's nothing red about it. The neurons firing in your brain aren't red either. They're just cells doing chemistry. Sodium ions flowing in and out. Electrical potentials changing. So where does the red come from? This is what philosophers call qualia. The felt quality of experience. The redness of red. The painfulness of pain. The taste of chocolate. These aren't just information. They're experiences. And somebody is home having them. Feynman once described it this way. Atoms with consciousness, matter with curiosity, a universe of atoms, an atom in a universe. That's the puzzle. How do atoms become aware? Now, wait. You might think we know the answer. The brain. Obviously, consciousness comes from a brain. But that's not an answer. That's just pointing at the box where the mystery lives. Let me give you an analogy. Suppose I ask you how a car moves, and you say, the engine. Okay, but what about the engine? Well, there are pistons. They go up and down. Fine. What makes them go up and down? Fuel explodes, pushes them. Now we're getting somewhere. We can trace the whole chain. Fuel burns, expansion, pressure. Pistons move, crankshaft turns, wheels spin, car moves. Every step is mechanical, physical. We understand each link. Now try the same thing with the brain. Photons hit the retina. Okay, electrical signals travel through nerves. Okay, neurons fire in patterns. Okay, and then, somehow you experience the color red. Where's that step? What's the mechanism? What converts electrical activity into felt experience? Nobody knows. We don't even know what kind of answer would satisfy us. This is what David Chalmers calls the hard problem of consciousness. Not the easy problems like how does the brain process information? How does it control behavior? How does it integrate signals? Those are hard engineering problems, but they're tractable. We can imagine solving them. The hard problem is different. The hard problem is why there's any experience at all. Why is all this information processing accompanied by an inner life? Why is there something it's like to be you? Let me put it another way. Imagine you could build a perfect robot. It sees, it hears, it moves, it speaks. It does everything you do. From the outside, it behaves exactly like a conscious being. But inside, nothing. No experience, no inner life. Just machinery processing information in the dark. Is such a robot possible? We don't know. But here's the point. From the physics alone, from the chemistry alone, from the neuroscience alone, we cannot tell the difference. Nothing in our equation says that certain arrangement of matter should have inner experiences and others shouldn't. This is what made Feynman so unsettled. He could calculate the precise movement of every particle in the universe, predict quantum behaviors with stunning accuracy, but he couldn't explain why any of it feels like anything. Let me tell you something that makes this even more disturbing. Your brain contains about 86 billion neurons. That's roughly as many stars as there are in the Milky Way. Each neuron connects to thousands of others. The total number of connections is around 100 trillion. But here's the thing. These neurons are scattered all over your brain. The ones that process vision are in the back. The ones that process sound are on the sides. The ones that process touch are along the top. Different features of the same object are handled in different places. The color of an apple is processed separately from its shape, separately from its location, separately from its motion. And yet, when you look at an apple, you don't see a red blob here and a round shape there and a location somewhere else. You see one apple, one unified experience. How? How does your brain take all these scattered pieces and bind them together into a single coherent experience? This is called the binding problem, and nobody has solved it. Some researchers thought they'd found the answer. Neurons that fire together wire together. If neurons in different parts of the brain all fire at the same rhythm, maybe that synchrony is what binds them. It's a nice idea. Neurons do synchronize their firing, often at frequencies around 40 cycles per second, the gamma rhythm. But here's the trouble. Synchrony doesn't explain experience. It just pushes a question back a step. Suppose I tell you that neurons A, B, and C all fire at 40 hertz. That tells me something about timing. But it doesn't tell me why that synchronized activity feels like anything. Let me give you another way to see this. There are neurons firing in my brain right now. There are neurons firing in your brain right now. Some of mine might even be firing at the same frequency as some of yours. But we don't share an experience. Your consciousness is yours. Mine is mine. Why? The neurons are just cells. They don't know whose brain they're in. They just do their chemistry. So what makes your neurons your experience? And my neurons my experience? I don't know. And as far as I can tell, nobody knows. Now, let me show you how deep this rabbit hole goes. Your brain is made of atoms. About 7 octillion of them. That is 7 with 27 zeros after it. Here's a question. Take one atom out of your brain. Are you still conscious? Surely one atom can't matter. You lose atoms all the time. You breathe them out, you sweat them out, they get replaced. The atoms in your body today aren't the same atoms that were there 7 years ago. So consciousness doesn't depend on any particular atoms. It must depend on the arrangement, the pattern, the information. But wait, the atoms aren't really solid things. They're mostly empty space. The nucleus is tiny. The electrons are somewhere in a cloud of probability. When you touch something, you're not really touching anything. Electrons in your hand are repelling electrons on the table. It's all fields and forces. So your brain isn't really a thing. It's a pattern of activity in fields. Electromagnetic fields, quantum fields. A constantly shifting dance of energy. And somehow, that dance knows it's dancing. There's an idea that's been gaining attention. Maybe consciousness isn't produced by the brain the way a generator produces electricity. Maybe consciousness is more like what electricity is to the generator. The brain generates electromagnetic fields. Whenever neurons fire, they create tiny fluctuations in the electric and magnetic fields around them. These fields extend through and beyond the brain. Some researchers suggest that these electromagnetic fields aren't just byproducts. They might be where consciousness lives. The unified field integrates information in a way that scattered neurons can't. When neurons fire synchronously, their fields add up. When they fire out of sync, their fields cancel out. The field isn't scattered like the neurons. The field is everywhere all at once. Is this the answer? I don't know. It's an interesting idea, but it still doesn't explain why an electromagnetic field should feel like anything. Magnets have fields. Radios have fields. We don't think they're conscious. Why should the brain's field be different? Some physicists suggested that consciousness might involve quantum mechanics. Roger Penrose proposed that quantum effects in tiny structures inside neurons called microtubules might be important for consciousness. It's a bold idea, but there's a problem. The brain is warm and wet. Quantum effects are delicate. They get destroyed very quickly in such environments. But here's the thing. Even if quantum effects were involved, it wouldn't really solve the problem. Quantum mechanics is still physics. It tells us how things behave, not why they feel like anything. Saying consciousness is quantum doesn't explain consciousness. It just makes it quantum and mysterious instead of classical and mysterious. We keep running into the same wall. We can describe the brain in more and more detail. We can map every neuron, trace every connection, measure every signal. And at the end of it all, we still don't know why any of this activity is accompanied by experience. Let me try a thought experiment that Feynman loved. Imagine we could record every single thing happening in your brain while you look at a red apple. Every neuron firing, every chemical released, every electrical potential changing. We store all this information in a computer. Now imagine we play it back. We recreate all the exact same signals in a different system. The patterns are identical. Does this new system experience seeing a red apple? You might think yes. Same pattern, same experience. But wait, we could slow it down. Play the recording at half speed. Is the experience now in slow motion? We could play it backwards. Does the system experience seeing the apple disappear? We could scramble the recording, play all the signals in random order. Is there still an experience? Presumably not. But why not? Every signal still occurs. Every component is there. The difference is the relationships between them, the structure. So consciousness depends on structure. Fine, but what structure? What makes one arrangement conscious and another not? Here's an even stranger version. Imagine we write down all the information about your brain at a single moment, all the positions and states of all the particles. We put this information in a book. Is the book conscious? It contains all the same information as your brain at that moment. You probably want to say no. The book is just ink on paper. It's not doing anything. Consciousness seems to require not just information, but processing. Change over time. But how much processing? And what kind? These questions don't have clear answers. Let me tell you something that really bothered Feynman. We know a lot about how the brain works. We know which areas light up when you see faces. We know which areas are active when you feel fear. We know that damage to certain areas causes specific deficits. All of this is wonderful neuroscience. But notice what it is. It's correlations. Brain activity A correlates with experience B. We find the neural correlates of consciousness. But correlates aren't explanations. When we find neural correlates of consciousness, we're finding where and when consciousness is associated with brain activity. We're not finding how or why that activity becomes experience. Some people think this is just a matter of more research. Once we understand the brain better, the mystery will dissolve. Consciousness will turn out to be an emergent property, like wetness emerges from water molecules. I'm not so sure. Wetness isn't really a deep mystery. We understand what it is for something to be wet. Molecules move around, they stick to surfaces. They flow. Wetness is just a way of describing certain behaviors of matter at a large scale. Consciousness is different. It's not just a behavior. It's not just a pattern. It's the fact that there's something it's like to be the system. That's a different kind of thing altogether. Let me put it this way. Suppose I gave you a complete description of a brain. Every atom, every connection, every process. And suppose I asked you to predict what the person would do, what they would say, how they would behave. In principle, with enough computing power, you could do this. The brain is physical. It obeys physical laws. But now suppose I asked you a different question. What is this person experiencing right now? What does it feel like to be them? The complete physical description doesn't answer this question. It can't, because the question is asking about something subjective, something from the inside, and the physical description is all from the outside. This is what philosophers call the explanatory gap. There's a gap between physical descriptions and conscious experiences, and we don't know how to bridge it. Now, some people try to avoid this problem. They say consciousness is an illusion. There's nobody really home. The brain just processes information and generates reports about having experiences. But there's no actual experiencer. Feynman found this absurd. An illusion for whom? If there's an illusion, there must be someone being fooled. And that someone is having an experience. The experience of being fooled. You can't eliminate consciousness by saying it's an illusion, because having an illusion is itself a kind of experience. And that tells us something important. Consciousness isn't like other problems. It's not going to be solved by the usual methods. We might need entirely new concepts, entirely new ways of thinking. Let me tell you what Feynman suspected toward the end of his life. And I want to be honest. This is speculation. This is a physicist at the edge of what we know, looking into the darkness. He thought consciousness might be fundamental. Not that everything is conscious, but that consciousness might be like mass or charge or space-time, not derivable from something more basic, just there as a feature of reality. If this is true, then we shouldn't expect to explain consciousness in terms of physics. We should expect to find laws that connect consciousness to physics, just as we have laws that connect mass to motion or charge to electromagnetic fields. This isn't a popular view among physicists. We like to explain things. We like to reduce complex phenomena to simple components. But maybe consciousness is where reduction stops. Maybe it's bedrock. After centuries of trying, after all our progress in neuroscience and physics, we still haven't made 1 inch of progress on the hard problem. That should tell us something. Let me leave you with this. You're sitting there right now having experiences. The sound of these words, the sight of this screen, the feeling of your body, all of this is happening. It's undeniable. It's the most certain thing there is. And yet, from the point of view of physics, you are a collection of atoms. Just atoms. Carbon, hydrogen, oxygen, nitrogen. Those atoms were forged in the hearts of stars billions of years ago. They floated through space, gathered into planets, combined into molecules, organized into cells, grew into organisms, and eventually became you. And now those atoms are looking back at the universe and wondering where they came from. Matter with curiosity. Atoms with consciousness. The universe waking up to itself. Feynman used to say that the most remarkable fact about the universe isn't that it exists, but that it knows it exists. That somewhere in this vast cosmos, matter has arranged itself in such a way that it can look back and ask, what am I? I don't have the answer to the mystery of consciousness. Nobody does. But I think it's one of the most important questions we can ask, because it's not just a question about the brain. It's a question about what we are. It's a question about what the universe is. And maybe, just maybe, when we finally understand consciousness, we'll understand everything differently. We'll see that the universe isn't just matter in motion. We'll see that awareness, experience, consciousness, these aren't accidents or byproducts. They might be as fundamental to reality as space and time themselves. That's Feynman's disturbing discovery. Not that we don't know the answer, but that the answer might force us to completely reimagine what reality is. Now here's what I want from you. This is the deepest mystery in science. The question that stumped even Feynman. If you had to bet, what do you think consciousness really is? Is it just the brain doing complicated things? Is it something more fundamental woven into the fabric of reality itself? Or is there something we're all missing? Something obvious staring us in the face? Drop your answer in the comments below. Tell me what you think, because this conversation doesn't end here. It continues with you. And if enough of us keep asking, keep pushing, keep refusing to accept easy answers, maybe we'll crack this mystery that even the greatest minds couldn't solve. So share your thoughts. Challenge me. Challenge each other. Let's see if together we can get closer to understanding the most profound mystery in existence. The mystery of you.